followed by a review of what I covered this month in physics, and then we're going to open up first the questions, the floor for questions that people have made since last time, and then real time. Okay, that we'll work in that direction. Okay, let's go with the first one. I got a lot of static for getting my shot. Okay, and so a lot of people didn't like that. And these are some of the I couldn't put all the comments that they put, but here's some of the comments that came up there. And first it says, all you had to do was wait a year and you could travel. And another fellow says, sounds like you're dying to go on holiday. And that's how the questions came, or the comments came out. Well, what can I say? In my case, everybody's got a different situation. In my case, the United States government has prevented my wife and I from living together for over 20 years now. So everybody's got a different situation. Then you still have to look at this whole thing in a different light, and again within the extinction theory. Okay, keep this in mind. And it goes something like this. Let's say they give you a sentence, a death sentence. You're going to the electric chair in 1 month. Here comes the doctor to your cell and says, we want to give you a shot in the arm. Not with a gun, right?
Get shot.
Yeah, I'll give you a shot in your arm. I mean, you're going to die in 1 month. Do you think you're going to care? They give you a shot? You say, yeah, go ahead. And it's more or less like that. And
yeah, you got something you want to tell me, buddy? You die in a month?
I didn't get the shot for a year and a half. I got it now because I had to travel, or I'm going to travel, and I don't want the hassle. And so they said something along those lines. Says someone said it's not a vaccine, it's a genetic serum. Okay. Now the fellow says you didn't take a vax, as it is not one. You took a gene therapy drug, and that is official. So some people say that I'm destroying my genes or changing my genes, I guess, by getting my shot, right?
You're mutating now.
Yeah, something like that. Someone says, look up Brandy Vaughan. And this lady died. She was in her 40s. She died quite early. Died of unrelated causes to the vaccine. But she worked for a pharmaceutical company, and became an atheist in pharmaceuticals and drugs, and in that whole business of medicine. And a lot of people are just like her, and so they look up to people like her who go out there and talk against doctors and hospitals and the whole business of medicine, right? And yeah, everybody reaches his own conclusion. There is a lot of commerce out there, and so I don't blame people who question all of what's going on out there, but again, everybody's got to reach his own conclusion. The issue, the way I look at it, you don't want to take an extremist view and become a flat earther in the medicine world. You can go with conspiracies as only so far, and after that it gets ridiculous sometimes. So just keep that in mind. That's the context. Okay, and final fellow said, you've been exposed as a fool. I will no longer watch this YouTube channel.
Exposed? It makes it sound like it's a secret.
No, but the issue here is it's that there's a lot of militancy and a lot of debate going on for this issue. For me, it's a non-issue.
I have a friend who if
if
his job made him vax to keep working, he'd quit. He told me.
Yeah. A lot of people are very strong in their beliefs, for and against this, by the way. Okay, for and against. There's a big debate out there. Lots of articles, lots of people talking about this. For me, it's a non-issue altogether. Okay, totally unrelated to anything that I do or even think about. I'm not even concerned about it. The only reason I got the vaccine is I don't want to fight City Hall. Okay, if you want to go fight City Hall, hey,
be my guest.
Knock yourself out. I don't want to go through the hassle. Let me show you some examples here. Here you have Chicago Tribune. Now asks unvaccinated travelers to quarantine. Okay. Washington Examiner, Biden administration tells unvaccinated people don't travel over Labor Day weekend. They're going to put all kinds of stuff in front of you, right? Barron's, Europe wants unvaccinated Americans to stay home, okay? So, and it's bad news for airline stocks. You better believe it. I wouldn't be buying airline stocks just now. Maybe later on, but not now.
Unvaccinated people are becoming second-class citizens.
Yeah, and look, here you get an even worse case. You talk about the government interfering in your life. Well, here, how about this one, okay? Here's this lady, and the judge asked a mother if she got the coronavirus vaccine. She said no, and he revoked custody of her son.
Wow.
So I don't know if you want to. I mean, if you want to fight City Hall, go ahead. I've got better things to do. Especially, I don't think I have that many years left in me, so I'm not going to fight this thing. It doesn't matter to me. Okay, you might think differently. I don't know.
I'm not vaccinated.
Yeah, but I mean, if you're on death row and you got, I don't know, a month to live or 2 months to live,
do you care if they I don't
think you would care. I don't think you would say, "Oh no, it's so against my."
Maybe out of principle, just to piss people
off. Yeah, that's the only reason. Yeah. But I mean,
you don't care
reality,
what's in the juice. You don't care what's in the juice. Yeah. It could be the death syringe itself.
Maybe it beats the electric chair.
Okay, just put it in.
Okay. Another fellow says the conspiracy theory around vaccines that makes sense logically. A person in his 50s, 60s, or 70s probably won't get harmed by it. Then again, a senior citizen in 80s or 90s might be too fragile to receive it. The vaccine is never personalized enough to the receiver's immune system.
That makes sense.
And and you keep in mind, here's something that came out on the news and gives you an idea where this stands, okay? You have WHO, the World Health Organization, monitoring new coronavirus variant named Mu. So we have the Mu coming on. And, they've got all these variants. Are they real? Are they not real? And, they vaccinate you against one. Does that protect you against the other? So we got all these issues out there. And again, that's why I don't care about the vaccine itself. It doesn't do anything for me as far as I'm
or coronavirus, because as far as changing our lives, it hasn't really changed much. But for me, it hasn't changed literally anything except
you have to wear a mask. Caught it.
No, well, you have to wear a mask.
Other than that, it's no biggie. And again, some people say, well, if you catch it, then you're going to be sorry. And you'll read tons of cases out there. You'll read tons of cases of people who got the vaccine and died anyways. You get all kinds of cases. You don't even know what to believe anymore. So
this is gonna be one of those 2020 hindsight things.
Yeah.
In hindsight, everyone's gonna be like, "Oh, you should have got the vaccine," or "Oh, you shouldn't have."
Yeah. Personally, I don't care about it. If I get the bug, assuming there is a bug, for those of you who don't believe that there's a bug, I die. And that's it. We're done. I mean, I don't care either way. And again, the only reason I got the vaccine is to travel, so they don't, hassle me. Okay, another fellow brings up the issue that says, previous to the viral scam, the medical industry was the third leading cause of death by admitted reported medical errors. Bill's mother probably lived longer by not going to this incompetent cluster. And I talked about the fact that my mother died of cancer to the uterus, died at the age of 62. Had she had an operation, she probably would have lived longer. This all thinks otherwise. But the issue there is that everybody's becoming, an expert in health. Everybody's a shaman now, everybody goes to Google whenever they have a problem. They say, oh, why does my eye hurt? Oh, it must be this. And so they try to cure themselves. One question there is, when the end of the world comes around, you're the last human on earth or one of the last few, right? Do you have a doctor available to you? I mean, you have all these preppers and survivalists. A hunter who goes out there and thinks he's going to be living off the deer that he hunts. And a prepper is a guy who is a gardener. He's going to be doing gardening. And so the question is, do you have a doctor? Do you have a dentist? I mean, here you start having a pain in your tooth, real bad pain, and there's no one around to cure you. Are you going to do what the guy in the movie
Castaway.
did with a rock?
You're right.
I hope you're brave enough, okay, to do it to yourself, because there's going to be no one around, to treat you. Okay. Had a couple of religious folk come around, says evolution BS, and another fellow also says Bill takes evolution for fact, then describes species degeneration. Okay, yeah, but see, these people believe in the Bible, and they believe that God turned silicon into carbon. He took a little bit of clay, okay, and made a man out of him. We do that typically in these accelerators. They are able to do transmutations, a little bit. God did it without all that machinery. He just took his hands and blew life into some clay and turned it into carbon.
Dude's got a point, though.
Oh, he does? Okay, what's the point? Okay.
That's obvious.
Okay.
Like, I thought evolution is about getting stronger and growing, and species degeneration and gene washing out over time is an argument for the opposite.
Yeah, in that sense. Yeah, but see, this is the problem there that I see is that people use the wrong words. What you'll find out there is that so-called scientists, biologists, whatever they're called, they go out there and they say, that he had the right tools to survive. Or they talk about better and worse. It's got nothing to do with better and worse or with being successful. These are the words they use. Those are all, qualifiers that don't belong in the discussion.
Of evolution?
Yeah, because what does successful mean? We're all going to die. All species are going to die eventually. So what do you mean successful?
It just means you had a kid before you died.
Yeah.
And that kid lived long enough to have a kid.
The language is wrong. Well, we shouldn't talk about success and survival of the fittest. It's not the fittest. It's the guy who survived.
What's wrong with success, though? Success is nice as binary. Did you live long enough to have a kid or not?
Oh, is that what it is? Is that what success is about?
That's how you define it.
And
yeah. Evolutionarily speaking.
Well, maybe, because I would say that success is the guy who doesn't have kids.
Or that, yeah. The guy who just enjoys his life and dies.
Right, maybe that guy's successful.
I'm saying, like, evolutionarily speaking, usually that's how they qualify success.
I know, but what I'm saying, that's the wrong language. They should not use that kind of language, at least in science. I mean, you want to talk about this kind of stuff at the water cooler, fine, but in science, you should not talk about success and survival of the fittest and all this kind of stuff.
There's also opinionated.
Yeah, it's opinion.
Success has that opinion weight to it. Like, well, if you call it success, yeah.
So this is the issue. I mean, wrong wording. Okay, another issue here. Fellow says, to support Bill's extinction theory, the UN's High Ambition Coalition wrote a document in 2020 that said a mass extinction event is well underway.
Uh-oh.
The UN also comes out a GAR report every 2 years, which discusses global collapse with scenarios.
But do those scenarios always involve pandemics?
Well, that's the next point. And the next point is, what are those mechanisms, scenarios, okay? And here you have, this is from the Wikipedia, okay? And so you've got first the ecological, this is the ecological group. What do they put? Climate change, pandemic, so we do have pandemic in
We're
there.
already halfway there.
Human activity, they say we're in the sixth mass extinction, okay?
By human activity, they mean like...
We're displacing animals and plants.
But not just that, it's also we're destroying our own environment for ourselves.
Yeah, essentially that's what they're saying, that but partly because we're destroying it, and partly because we're clearing the land, the forests, the jungles, so that we can plant stuff that's good for us. So it's all a mixture of all that, and by doing that, we're displacing all the animals. We're crowding them out. Nitrogen fixation, they talk about the nitrogen cycle, like if that's got something to do with anything. Freshwater depletion, overpopulation. Okay, they say that we are using up resources faster than can be naturally replaced, okay, or replenished. Birth rates rising in the 21st century in the developed world. That might happen, they say, okay? And Science, the magazine, says human population will grow to 11 billion by 2100, and that growth will continue into the next century. So these are what these people have in the backs of their minds. So what I can say to that is these people have no clue whatsoever what they're talking about. Okay, because population is declining. It's declining irreversibly.
Population growth is declining.
Population growth is declining. It's declining irreversibly, and that means we're going to reach ZPG at some point. Quite soon, I believe.
Well, irreversibly is
irreversible. No,
that's
exactly.
Your
And I'm
take
saying,
on it.
and I'm saying that irreversibly because our population pyramid has overturned. When it does for any species, it can never be turned back again. And what I mean is, when a species is old, not when it's young, it's just had a bottleneck, of some kind. Okay, anyways, population decline through a preference for fewer children. Okay? In developing world, demographics are assumed to be developed world demographics. Some projections suggest an extinction before the year 3000. And this fellow, Leslie, mathematician, he says, well, it might even happen in the year 2400. Well, how about if they consider that it might happen in 6 years or so? Could that happen? And some models suggest the demographic transition may reverse itself due to evolutionary biology. Absolutely not. Never will happen. Okay. And then, of course, you have the supervolcanic eruption. You have to put that one in there.
I had to finish it with a bang.
Yeah, because that's how the Permian animals supposedly died. There was a volcanic activity because that's the pet peeve of the people who work in the Permian extinction.
It is badass.
Yeah, it's great, but you can't explain selectivity with that. So
yeah, you can. The coincidence. The rocks hit the right dudes.
Yeah. And then that was the ecological. Now they have another set, and it's the technological. One is the nuclear and biological weapons.
Sorry, I saw extraterrestrial. I had to laugh. The aliens are coming.
Yeah, more or less. Then they have mitigate disease outbreaks. So we have again diseases in there. Okay. Creators of super intelligent entity. We're going to create these super intelligence. These robots.
Terminator. They're actually talking about Terminator.
Yeah, they're going to kill us.
We're going to make AI that's smarter than us and then finds us obsolete and kills us.
Right, something like that.
They've actually been watching too much Matrix.
Yeah, that's what it is. A lot of too much information.
And even then, the Matrix doesn't kill us. It just makes us.
Well, that's in the movie. Not in reality.
Oh, in reality, the robots will kill us.
Uncontrolled nanotechnology, creation of a micro black hole. I mean, these people really are.
Man, you never know when you make a black hole.
Oh yeah.
Sometimes they go into the bathroom and make some.
And then you have genetic engineering creates a new species, so we become something different than we are today. They're known as post-humans or transhumans.
So that would be would that be like an extinction that they suspect the Neanderthals died of? The fact that the Neanderthals didn't die out, they just turned into us. So in that sense, we would die out
because we turn
into the next thing.
Yeah, but it gets worse because in the case of transhumans, you don't need their body anymore. It's just the intelligence floating on the internet.
Yeah.
So
I've read fiction about
now
that.
That is the Matrix right there.
Yeah.
Okay, extraterrestrial, especially NASA sponsored. Okay, geological or cosmological disaster, extraterrestrial event like asteroids, etc., supernova, gamma ray, that kind of thing. Sun's stellar evolution might happen in 1 billion years. Heat death of the universe. Now we're talking about billions of years, and then we can be invaded by militarily superior extraterrestrials. And of course, if they invade us, they absolutely must be militarily and otherwise superior to us. Is there any mention of food collapse due to the fact that our economy collapses?
Okay, now you're pulling straws. Come on, now you're pulling at straws.
So why isn't that theory in the Wikipedia? Okay, why do we have all these idiotic theories?
It's not even on there. That's kind of weird that food shortage isn't even.
Yeah, it's not even considered. It's like nobody even ponders the fact. You go to the supermarket, food's there. What do you mean, Bill? What are you talking about?
It's not even like considered, like written down, but this is unlikely. It's not even like that. It's just like, it's not even.
Pondered. Not even discussed. Nobody even considers an economic collapse. And so the question is, all these UN guys, all they talk about is the same nonsense that the paleontologists, the mathematicians, all these people feed them. Posthumanists and futurologists, they all talk about the same thing, but just all this nonsense that I just read. No one talks about economic collapse. And so the question you should ask yourself, because very few people visit this site, is you're one of the few, at least, that's exposed to the theory, whether you believe it or not. But the question, you're exposed to it. The rest of the world is completely blindsided to it, especially those people who run the world. They're blindsided to it.
That's true.
Okay.
Even preppers are blindsided to it because they have like a close version.
A close?
They're close because they think it's gonna be like a dip and then come back. So you just have to prepare for the dip, wait it out, and then it comes back. But so they have like an approximate version, but they don't have this version of this is it.
That's one issue. The other issue is that a lot of these preppers and survivalists, they're just thinking about catastrophes, like maybe there's a flood, and so I'm going to get ready, go to the mountains with my gun, that sort of thing. Okay. Fowle says, what do you think about American elite building underground bunkers? Will they have a chance?
Are they building bunkers?
Well, I mean, we don't know that they are, but let's assume that they are, okay?
I guess we wouldn't know that they are. Right?
Yeah, it should be a secret, but assuming they are, the problem is not building bunkers. Anyone can build a bunker or whatever. The issue is, can they survive even within the bunker?
It's a self-sustaining bunker.
Yeah, it's got to be a self-sustaining bunker. That's one issue. The other one is that, who are they going to put in there? Are they going to put their bodyguards in there? Well, the bodyguards won't have to respect them once they're down there. Sure. The important thing after the collapse is that you have people you can trust. That's more important than saying, I'm going to build a bunker. You can build a bunker, but if you don't have a doctor and you have an appendicitis, need an appendix, what is it? You need an appendix operation, you're dead. You have no one to cut you up.
You got people, but
they're all dead. They're all dead. They all died.
No, you can have a guy who isn't a doctor do it.
Yeah, I mean, if you trust him, otherwise he's going to use the knife for something else so that he has more food for himself, right? Okay, and final issue, someone says, I will tell you where the sun is, Bill, because I'm saying here in Frankfurt we had no sun in the last 3 months. Says 4 months of sun is in sunny Oslo. Okay, and here, all I can tell you is what happened to me, and that's that, I put plants in my garden. I have a tiny garden, and here you'll see that the circles, those are peppers. And here you see cucumbers, but they're so small. You need a telescope to see them. Yeah. I didn't even think they were going to grow, and I just saw them by mistake a couple days ago, and they're growing fine. I guess they're going to grow, but because there's been no sun, I don't even think they're going to make it. I plant plants only to learn about them, okay, and not to feed myself. Fortunately.
No, we do have really nice, the spicy peppers, the hot peppers.
Oh yeah, we have.
Those are nice with chicken.
Yeah, those we do eat. But other than that, I don't have a big garden. Okay, let's get on to the recap for the month of August, and let's do a.
What did you talk about in August?
Okay, we talked about transparency, opacity, reflection, refraction, and the faster than light travel of light. Light travels faster than light. All these have to do with the properties of light as it meets objects, specifically objects people are concerned about, like glass, water, air. They say, well, here we had light go through this material and it's transparent, and then for some reason it doesn't go through the wall, through your cement wall. And you say, why is this one opaque? Why is that one transparent? So we looked at this. And the first thing I want to mention is, one thing is for me to explain the mechanism under the rope model of how transparency works, how opacity works, reflection, and so on. That's one issue. Another issue is why. Why is this material opaque? Why is that material transparent? I haven't gotten to that because right now I have problems getting people to understand what I'm talking about. And I'm trying to compare, especially quantum mechanics, mathematical physics in general, against the rope model. And people keep talking about going through, traveling through. They say, well, how does a rope explain traveling through?
Well, that was something that you told me that you opened my eyes to the other day, where I always thought also like the light just goes from my eye to the light bulb, but then you were like, no, there's a big wall of air between you.
People don't believe it.
So it's that air relaying from air molecule to air molecule the light
All
to
the way
my
to
eye
your eye.
and back.
Right.
And I always thought of it in terms of like in space, it would go directly from the light to my eye because there's nothing in between. But on Earth, it isn't the same mechanism, I guess you could say. I mean, it is, but there's more steps in between.
Yeah,
It's more like what do you call it, the Newton's cradle, where one
And
it hits a whole bunch of balls and then it hits the one on the
exactly.
end, something like that.
What we fail to realize is that what I have here in front of me, which I take into my nose,
it's not playing no part.
It's a physical object.
Yeah.
And the question then becomes, does light go through physical objects? Through objects. Does it go through objects? And people say, well, it goes through air. Well, does it? And so they use this term, go through, travel through. And right now I have a big problem just getting people to understand the theory, what I'm proposing. So I'm just explaining the mechanisms of refraction, reflection.
Before we even get to a passage.
Before we can get to the question of why, why is this one like that? Why is that one like something else?
What have you explained?
Well, so let's look at this. Here we have quantum mechanics. Well, first of all, here's all these properties in one picture. We're going to assume that's a piece of glass, somewhat transparent. So some of the light goes through, you can say, right? If we're going to talk about going through, that's why I put a dotted line there. That's the way quantum sees it. So some of the light goes through, some of it refracts. We don't know why, but it turns a corner, right? Sharp corner. Some of it reflects, comes back, and some of it is absorbed, and whatever is there is opaque. And so these are the possibilities. Okay, and that's what I
guess
covered.
that all happens simultaneously.
Well, to some degree, I think it happens with all materials, and I think quantum will agree with a mathematician. They'll agree with that, right? But here's the quantum reasoning. Okay, this is, if you can call it reasoning, this is their line of reasoning. Okay, and what we have here is, the first argument is that there are many atoms between you and whatever you're staring at, and that was how stuff works. Officially says this, and they're pretty important. I mean, they represent the establishment, and they have people who are PhDs working in there, and this is what they're saying: many atoms.
What does that mean?
Well, that means that if you put more air atoms between you and the window, you won't see the window, and the answer is no. Period. At night I can't see the window, but if I turn the light on, a flashlight on, I can see the window. Have I put or subtracted or put more atoms in between my eyes and the window? Obviously not. Something else is going on. So it's not a question of how many atoms I'm going to put between my eye and the window.
That's the wrong counter experiment.
Okay.
The right counter experiment would be, can you compress air to the point where you can't see through it anymore?
Well,
if you had like a tunnel, and
again,
in that tunnel you compressed air, had so many atoms in one place, could you at some point not see through it?
Well, we don't know. Maybe we could do some experiment like that. My point here is that, when I look through 3 feet or 10 feet of water, I can see my reflection at the bottom of the pool. And we did the experiment here with Hans where we put a mirror in a trash can at the bottom of the pool. And we filmed you only have air there, so you can see yourself and you say, okay, no problem, there's nothing there, right? As if there is no air. Then we filled it with water, and we can see that the light continues to go through the water all the way to the mirror, comes back to our eyes. So light is going all the way, if we're going to talk about going through, light is going through the water and coming back up. Does the photon go through all those atoms back and forth?
Without hitting anything?
Yeah, without hitting anything. And when you have only air, it goes through all those atoms of air and comes back. When the light comes from the sun, it goes through all, we have air all around our planet, a very thick layer of air, because that's why we can breathe, right? And here we have the sun, this little photon. It's got to make it through all those gazillions of atoms all the way to your eye.
But I still think they're right. The more atoms that are between, the more atoms that are there, the more opaque the light gets. I mean, we know this because if you look off into the distance, which is basically you're getting the most air atoms possible. When you look off into the distance to a mountain, it gets like blurry because there's so much air between you and the mountain.
Is it? Or is it distance and dust and other issues?
Yeah, but I'm just saying, like, dust also counts. Like,
Yeah.
I think the more atoms you have, it does block light more, but not to the extent that you could probably block out light. Like, you'd have to have a lot of, because like even in under the rope model, air molecules lose some of the torque or the torsion, the energy, whatever you want to call it, in the relay.
Yeah, and
So
that's
if
why
you have enough, it would lose all the frequency, or it would retard the frequency down less.
Okay, but let's get to that point, because that's the other argument that these people make, and that's this one says, first of all, an atom is mostly empty space. So if an atom is mostly empty space, according to the official version, right, then all atoms should be transparent, all of them. We should see through cement walls. And so they say, okay, but the way they explain why something is opaque says, electron absorbs a photon or energy, whatever you want to call it, and that's why it's opaque. Okay, great. What is transparency? Well, transparency, electron re-emits. It absorbs and re-emits. That's one argument they make. The other argument is the electron doesn't get pushed to a different energy level. Okay? So we have these two arguments that if the energy of the photon does not affect the electron that's rolling around, then it goes through and it's transparent. Otherwise, it's absorbed by the electron.
Why does it affect it in some cases and not in others?
Well, yeah, they haven't explained that. They just say it is.
They all have electrons.
They say it is so. But there's a worse problem with that, and that's the more fundamental problem, which is the photon is a point particle and the electron is a point particle. And you're telling me that for all these photons that come in and all the electrons that are buzzing around in a material, air, water, whatever, glass, you're saying that all these photons that came through, they happen to hit that electron and knocked it into a different energy level? Is that what these people are saying? So there's a lot of problems with that.
I think we have the analogy for that. It's like a fly bumping into a mosquito in the Sahara Desert.
Yeah, more or less. And so,
what are you doing here? Like, it's the only two in the desert, but they somehow find each other.
Then we have reflection. They say, well, the energy bounces. In other words, the photon bounces. That's why you can see yourself in a mirror.
The photon bounces off the electron?
Or maybe it's against the proton. They never specify that. What is it bouncing against? But they just assume that you understand that the photon is hitting a brick wall and coming back when it hits the mirror. Okay, that's why you see
that I can see because it's like a ball hitting the wall. And
but when you get to the atomic level, now you're talking about,
yeah.
Did it hit an electron? Did it hit a proton? Did it hit a molecule? What did it hit?
Not only that, why does the mirror bounce it back better than a wall?
Yeah, or why does it bounce it in a given direction? Yeah. Why do you see yourself straight in the mirror? When you stand straight in the mirror, you see yourself directly. All those photons are going back and going forward, and the molecule that makes up the mirror is not a very smooth molecule. So if it hits an electron, goes that way, and then it hits a proton, goes in a different direction. How many of them come directly at your face? And it turns out you look at yourself in the mirror, and it's like a mirror. It's a mirror image. 100% of them hit directly straight back to you. Okay, refraction, same thing. What happens there? They never explain it. They just introduce Snell's law, talking about angles. Okay, and they never say that's a description, mathematical description, not an explanation. So you never learn what it is. Diffraction. They say a photon can be at two places at once. Great. And then they finally...
That's all you got to say to that for that one? Great.
Yeah, I mean, who's going to believe it? I mean, what kind of explanation is that?
What do you have against the photon being in two places at once? It's not two photons, it's one in two
it
places.
does happen when I drink a lot of beer, then I see the photon at two places at once, but that's an observer-related phenomenon.
It falls apart.
And then at the end, they give you the icing on the cake. They say, we don't understand it, and that's philosophy anyways.
That's always the punchline, isn't it?
Yeah,
So why did I even come to you?
Yeah.
Where are the actual scientists?
Yeah, they say, study math and you'll understand it, okay? So we never understand anything from quantum mechanics, okay? So that's why, I have to explain the mechanism first, okay? Before we go into why this is opaque, why that is transparent, okay? And so here's one question, important question for the mechanics. Here you have particles representing the light, in other words, the photons, and then you have the waves, the famous transverse wave. And you have particles that travel slower and particles that travel faster. You have the same thing for the wave. So the question is, why can't particles travel faster than light? Why can't the wave travel faster than light?
Because then they'd bump into the guy in the front, right?
And so that's one of the questions that you really want to ponder, okay? That's another issue that I raised this month. Okay, getting back to this, here we see the following. We have at least three proposals on the table. We have the particles, we have the waves, transverse waves, and now we have a new one since at least the beginning of this century, which is the rope. We're saying it's a torsion along a rope that physically interconnects any two atoms. Okay, so we have three proposals on the table, okay? What's the problem with a wave? Well, here's the wave version.
What is it?
Yeah, well, that's one issue, but here's the wave explanation. They say the wave goes through glass, okay, and that's why they talk about traveling through, okay? So they use that term, goes through, travels through. Okay, in the case of the rope, we're talking about relaying. Okay, there's nothing traveling, and so this is sometimes hard to get to people's brains because
throwing a ball is just easier.
Well, one is that. The other one is that everybody's been drilled to exhaustion on traveling through, that's the only terms that they use. And I'm saying that under the rope model, you have to think in different terms altogether. You have to talk about relaying from atom to atom. There is nothing moving from left to right. The atoms are, for all we know, we could be moving the glass for sure. But if everything in the universe stayed where it's at right now, we would still have the rope torquing and the atoms pumping. So you don't have to have light moving from A to B. What you have is torsion, okay? And so we have a different mechanism, and until people really get their brains around that.
It's a ball spinning a drill bit to pump a ball, basically.
Yeah, and what you're doing is relaying that signal to the other atom.
The ball pumps,
spins,
like torques the drill bit, and the guy on the other end gets the pump. He passes it on.
In fact, the torque goes both ways.
Yeah,
that's the other issue. And that gives you an idea of what reflection looks like. Why reflection is straight ahead. Rope is taut, and when you look at yourself in the mirror, every atom in your body, every single one of them, is mirrored, to use that term, in the mirror. Okay? It's straight ahead, back and forth, along the same rope. Now it's easily to understand the mechanism. But when you say, well, hold it, the little particle hit the mirror, and why did it ricochet in, to the right or to the left? That's the question you got to ask yourself with particles. Waves, well, the question with waves is we have no object called a wave, okay? There's no object in physics called a wave. Wave is a verb, okay? So you got to identify the object that is waving, the flag waves. But the wave doesn't wave.
Yeah, what are the arrows?
Yeah, and so the arrow right there, you see vectors are represent quantities that have both magnitude and direction. So the arrows are vectors. What the mathematicians have done here is they put a mathematical concept and they represent it with an arrow. The arrow stands for a vector. What is a vector? It's magnitude and direction. And the worst part is they have these vectors moving. Very scary stuff.
Moving 3 north.
Yeah, you have a number that has direction. If you can conceptualize that, you got to replace it with an Indian arrow, right? So you put an Indian arrow, you put a bunch of these Indian arrows that represent magnitude and direction, and then you put them in motion.
What's going on? It reminds me of the Dumbo part where Dumbo gets drunk and it's got all the pink elephants. Dum 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 dum. He just starts hallucinating. It's like that. Like, what are you moving? What's going on? What is that?
So mathematics doesn't have a physical interpretation. So whenever you see a wave, ask, what is it that you're staring at? What you're staring at is a bunch of moving vectors. What is a vector? Well, it's something already in motion. It's a number in motion, number that has direction, right? And now they're going to move it in a different direction.
You can't move a number. Like, you can't move the number 3.
Well, it's worse when you try to move a moving number 3.
now
we got motion.
I don't know what you're talking.
We got 2 levels.
Did you understand? No. Well, go to the university, and then you'll not understand like we do at least.
Okay, and it doesn't stop there. We have the wave, which is nonsense. We have the particles, which are not particles. What you're talking about is a wave equation. You know, you're talking about a when you're talking about particle, you're talking about a wave function, whatever that means to you. It's just a number that they put at a location. They have all these locations moving. So they don't have a physical object. Ask any quantum mechanics, and if you say, well, do you really have a corpuscle there? And you'll find out what the answer is. The answer is no.
Is it a ball? Well, that's a metaphor. It's
they don't have corpuscles
representation.
anymore.
The number is a representation. It's a metaphor.
Okay. And so it's all concepts, especially dynamic concepts, which are also moving. And then planetary atom, nonsense. You can't explain why the electron doesn't fall to the center of the nucleus, or why it doesn't, drift away spontaneously. I mean, what keeps the electron faithful to the atom? That's what you got to explain. And if you cannot explain that, you cannot even start your presentation. Electricity, the flow of electron beads from atom to atom. What is compelling? What's coming in contact with each electron to move it? You got to explain this. You got to justify it, and they don't. They just say, well, electricity is the movement of electrons. Okay, what compelled the first electron to move? What came in contact with it? And what they're going to do is introduce a concept: force, energy, field. They can't tell you a physical object hit that electron, compelled it to move to the other atom, and supposedly it either hit the other electron and kicked it to the next atom, or that electron, for some reason, already left a hole, and this guy occupies it.
Whatever leaving a hole means.
Yeah. And so the question is, what triggered that first electron to move? I mean, what came in contact with the electron?
The light switch.
Yeah, but see, electricity is not really a light. It's not a photoelectric effect where you hit the electron with light. Okay, that's not what electricity is. Electricity works a little differently. A battery works chemically. And the question is, what triggered that first electron to move? Okay, we have the beginning of motion, which not even God can explain. Okay. So what do we say? Well, light does not go through walls. Okay, it doesn't go through walls of bricks, walls of glass, walls of air or water. Okay. What we have is atoms attached to atoms, and the signal is relayed from atom to atom.
Are the brick wall atoms just greedy and they just don't relay it? Is that what it is? They just absorb the whole torque? Well, don't pump at all?
Right now, all I want to, before I get into that, because I don't want to get into that issue, right now, all I want to show is that first, quantum does not have an explanation for travel through. Because they have all these different interpretations, then they finally give up and we don't understand it, and it's philosophy anyway.
Sometimes
that's in a nutshell.
Sometimes I wonder how much further down the rope hypothesis rabbit hole you would have gone if you didn't waste so much time with mainstream physics.
Well, you got to someone once told me, first you got to destroy quantum mechanics before you introduce your theory. Yeah. So part of it is criticism, and part of it is proposing an alternative. So I have both.
But again,
first I want to show what's wrong with quantum.
But I just wonder how much that slowed you down. like, because there's a lot of rope hypothesis mysteries that you can never really get to because you spend a lot of your time still just debunking what most people accept
take for granted.
Just on authority.
Well, that's true. I mean, I could look at different things that different phenomena out there that people have shown or seen in an experiment or observation or whatever. And so they say, well, how do you explain this? How do you explain that? And we could go into all that, but right now there's this big battle getting mathematical physics out of the way.
Well, a lot of it
all nonsense.
I think also it's more if the rope hypothesis were at least accepted to the extent that people would run more experiments with it as a basis, then the experiments could have different conclusions, interpretations.
Obviously.
Like
Yeah. Okay, so here we have the problem with speed. Good old Einstein is crying, as you can see, poor Einstein. Why? Because Einstein proved mathematically, and he's at least credited with having proved, that photons travel at a constant speed, and you do not add the speed of the train to the light that is coming out of the flashlight that you have on the train. Okay, so he said photon travels at the same speed no matter what. And it has a speed limit known as little c. Photons travel at 300,000 kilometers per second. But we could live with that because, otherwise we can't travel to the nearest star, even if we traveled at the speed of light, which we're a little distant from. And so the issue is that they had to invent this tachyon, and they also invented warp speed for Hollywood so that, the Enterprise could travel to Klingon land, at the speed of thought, you think, and you're there. Okay.
Doesn't the tachyon come from the future or something?
Yeah.
He's running the marathon backwards.
Yeah, but again, they want to cheat. The point is they want to cheat on the speed of light. And why? Because imagine if NASA told you, look, it's confirmed. No one can travel faster than light.
I thought that was confirmed.
Yeah, I know it was, but they had to overrule
that. There's like an asterisk at the end of it, but
you have this loophole, to the law, and they had to do that because otherwise you'd lose hope that we'll never get out of this planet.
And if you lose hope, you lose backing.
And, NASA would not have funding.
Hurts the wallet when there's depression and
because
hopelessness.
Why are we going to Mars? Assuming we ever get there, but let's assume that we send a few astronauts there someday. Okay, great. Does that mean we're going to colonize Mars? And we say, well, yeah, we will. Okay, and the question is, what for?
So we have Earth 2.
Yeah, but Earth 2 is a quarter of the size of the Earth.
Yeah,
you got a little planet there,
which
you have to terraform.
Yeah, we terraform it like that.
Yeah, in a few 100,000 years.
We snap our fingers, it's there. It's badass. You don't want to go to Mars, man?
Yeah. In Hollywood, we can do anything.
Okay,
but that means you have your feet off the ground.
One reason for sure to go to Mars is kind of like my brother goes to Iceland with his wife, like to see the sights. The nature of it. When you on Mars, they got I think Mount Olympian or Mount Olympus or something. It's like humongous
the biggest
mountain.
One,
yeah, like just to see that, you're like, that's a tall. Imagine standing at the top of that, I think they also have like a Marianas Trench kind of thing that's even deeper than the Marianas Trench. Just looking down that chasm would be cool.
Yeah,
but aside from that, it's just Earth again.
Okay, and here you have a proof that light not only travels faster than light. Light travels instantaneously. It's known as entanglement. They say one particle is connected to somehow. Connected with a.
It's connected to.
Yeah, you got to take that as a.
With a grain of salt.
Yeah, it's connected to another particle that's on the other side of the universe. When this particle goes clockwise, the other one goes counterclockwise. And if you turn this one counterclockwise, the other one instantly, gazillions of miles away, turns in the opposite direction. So they have all these explanations, these physical interpretations that involve not only faster than light, but instantaneous. In other words, you snap your finger, you think you're there, you're already there. So what have we learned about the physical, how Mother Nature runs her universe? That's the issue. You won't get it from mathematical physics or any so-called scientists out there, okay? What are the conclusions? Okay, here we have it. Light does not go through. That's the main point I want to make. It doesn't go through walls, through atoms, through molecules, through air, through water, whatever. It doesn't go through.
It goes to.
Right, it goes to, and then it's relayed, okay? So light is not made of particles or waves. Light is an interconnecting rope, okay? And again, it's relayed, and the speed of light is constant because of that. Why? Because you exchange frequency for wavelength, okay? And now with that, we can explain, some things. For example, why reflection is instantaneous and straight ahead. I mean, every atom in your body is reflected not only instantly, you could say, right? I hate that word instantly because instant involves time, but it's straight ahead first of all, and then it comes directly to you. And the only way you can really explain this is if you have a rope there and it turns in both directions, then it's easy to understand this. But if you say, well, hold it, the particle goes from my eye to the eye in the mirror and then comes back at the speed of light? Is that what the particle does? And why does it bounce sideways or in a different direction?
The ball, it feels like it has room for error, like it could miss.
Yeah.
A rope can't miss.
Yeah, rope can't miss. Wherever you go, and here you see it, okay? This is the retroreflector stuff that the mathematicians propose, specifically relativity. And what you have is the laser being pointed at the retroreflector on the moon, and that's it.
I like that gift.
Yeah, and we're not talking about flat earthers here who don't believe that that we went to the moon or anything like that. But we put a retroreflector on the moon. In fact, there's 5 of them: 3 by the United States, 2 by the Russians. And what they do is they point a laser at the location, more or less, where the retroreflector is, and they get something back. And the question is, how do you show this with photons going one way? First of all, right? Because it moves, right? And so it's going through warp space on top of that, and both the moon and the Earth moved. So how do you explain this? You can't explain it with particles. You can't explain it with waves.
You explained it right there perfectly. We caught the balls. We're playing ping pong with ourselves.
Okay, and and then the final one I want to show here is under the rope model.
That's my
See how easy it is. If every atom on the Earth is connected to every atom on the moon, it doesn't matter if you put a retroreflector there, because every atom of the retroreflector is connected before you even start the experiment. Before you turn the laser on, it's already connected to that laser. Okay, to whatever material makes up the laser. And so the moon can go anywhere it wants in the universe, and light will find it because light travels along the ropes that interconnect any 2 atoms.
The moon can go anywhere; it will be found. The moon owes the Earth money.
We will find you. We will find you.
You owe us money, moon.
Okay, so let's go with some of the questions and comments that people made. Okay, one fellow says steam doesn't have shape.
Oh, what? Wait, that's a question?
Yeah, he questioned because I'm saying that steam doesn't have shape. He says, steam doesn't have shape? No, steam moves around, okay? Steam is equal to boiling, not to water, okay? Shape is a static concept, so boiling is not. So the problem is when people talk about steam, they think they're talking about water. No, they're talking about boiling. They're referring to the verb. That's what the word steam embodies.
Does it?
Yeah, well, I'll get to that in a minute. I'll explain in more detail. But steam doesn't have shape. Ion doesn't have shape. Okay, ion is a process. Ion means you got to remove or put an electron. Remove, put, verbs. Sorry. Plasma doesn't have shape. You have to remove and put in or put in an electron in order.
Something is plasmaing.
Yeah,
it's like saying solid has shape.
You have to ionize it. Ion is already a verb. Ion means something is happening. Okay, and so this fellow continues, and he says
plasma was a state.
That's even worse.
That's even worse.
That's let me just quickly address that issue. To say that plasma is the 4th state of matter, as the people in the electric
solid,
universe,
liquid, gas. Plasma.
Right, they say this.
Super hot.
Obviously, if that's the definition of the word plasma, we're going to the definition here, okay? We're saying if we're going to define the word plasma as the 4th state of matter, clearly there's no physical standalone object called the 4th state of matter. What you're talking about is a comparison against solid,
Yeah.
against liquid, against gas. That
Solid
means,
isn't an object.
right. And so people, the people in the electric universe have never understood that. It takes them 10 years to understand something so simple. If that's the definition of the word plasma, don't ever use that definition again, because otherwise you're saying that plasma is a concept.
Unless they're
Okay?
talking about blood plasma. That does have shape.
Okay, but let's get to this issue here. The fella says, I'm so confused. Is gas an object or a concept? Defer, meaning me, right? That I defer to the Wikipedia and dictionary.com for definitions, but then dismisses dictionaries and the like as worthless. Aha. Okay. Steam is water as a gas. Aha. Is that what it is? You define a gas as an object. Steam is a subtype of gas. Therefore, hence, steam is an object, according to him. Okay, or he's trying to saying that if he applies my reasoning, he ends up saying that steam is an object.
I'm on his side.
Okay, good.
I
Will you follow up by saying water is a concept?
Yeah, will you follow up by saying water is a concept?
Okay, so let's address this issue, because he's not the only fellow who has problems with this. Okay, lots of people. You have a problem.
I have a problem.
You need to see a psychiatrist, better yet. Okay. Okay, so let's go with the answers to this. Okay, and bear with me. We're going to go through several words. None of them are scientific. In other words, we don't care about them in science. I'm just going to go to whether these words represent objects or concepts. Okay, they don't make or break anything in science in the sense that all theories of science fall apart because of these definitions. No, I'm just going to go to whether these words represent objects or concepts. Okay, so let's keep the context property in there.
Pop quiz.
Yeah. Okay, so here we have the word fog. We typically don't think of fog as something moving. It's like fog is just that thing that blocks your windshield and does not allow you to see.
I mean, it is technically moving.
Everything is moving. Everything in the planet is moving. I'm just saying the word fog embodies no motion, and you see the word there, suspended. Suspended is like a static verb. You know, we're not talking about something moving. We're saying it's standing still in the air. That's what the word fog means. So you're talking about a tiny drop of water that's standing still. So fog in general, when we talk about the word fog in ordinary speech, we're not thinking of something that's really moving. That's different than steam. Steam, it says, due to boiling. Steam does not equal water. Steam equals boiling. When we think of steam, when we talk about steam in ordinary speech, again, all these words are from ordinary speech. They have nothing to do really in a scientific sense. But when we use the word steam, we're thinking about something that's moving because we're talking about boiling it. Anyone who thinks of steam is thinking about boiling.
I think all of these except fire and flame are
Well, that's what I'm going through. Vapor talks about temperature. What is temperature? A verb. Okay, in science. In ordinary speech, temperature is a noun. In physics, for the purposes of physics, temperature is a verb. So is the word condense. It's a verb. Okay, so vapor has something to do with temperature and condensing. It's a verb.
Is it correct to substitute these words for water?
No, but here.
Assuming someone wanted to use these in a scientific.
I'm getting to that because the issue here is context. Context is everything.
Yeah, but
here.
in science, if someone wanted to use the word vapor as a noun,
it's going to have to be related to whether it's the context. And let me finish here, and you'll see why. Aerosol, suspension of fine solid particles. Fine, but but usually when we talk about aerosols, we talk about spraying. You know, aerosol is something that you spray in your house. Usually that's the case. And you see there it says aerosol spray that delivers, etc., etc. Okay, so usually aerosol is used in a dynamic concept, in a dynamic context, even though it's defined as suspension of fine solid particles. Okay, again, the word suspension meaning no motion.
It implies the motion of the particles is throwing out.
Right, and I'm talking about how we usually use these words and what the context is. It depends on the context that you're going to put them in. Mist. Well, mist, it says phenomenon. Phenomenon is already a verb. Okay, caused. Verb, okay? And you see dispersion, exhaled air, cooling, it's all has to do with motion, okay? And that's the notion we have of mist. When someone talks about mist, usually think about something spraying or something that's coming out, that's moving. That's not the case usually with fog or with a word like cloud that you see there at the bottom. Okay, smoke. Smoke, it again depends on the context. If you're talking about smoke, like you took a picture of smoke, well, then you're talking about that gas, that fog that's in front of you, that cloud that's in front of you. If you're talking about smoke like coming out of a fire, then you're talking about something that's in motion, and people in that sense, under that context, will think of smoke as something that is in motion. Okay? We have the word fire. What is fire? Well, fire is an oxidation. It's a process of combustion. And what is flame? Well, flame is usually refers to one of the components of fire. It's like if you pulled a piece of fire out and you took a picture of it. Okay, so flame, even though flame we know is moving, right? We all know this, right? Because it's a combustion, right? But the word flame usually refers to that piece that, like if I take a picture of fire, right? And I show it to a kid, and that more or less, I guess, a 10-year-old kid, right? He would say, that's fire. And what's that picture there? Well, that's flame. Here, let me illustrate that for you so you know what I'm talking about, okay? Here's fire. If I can see it, well, get it at the bottom here. Give me a second. Here's fire, okay? That's fire, okay?
No,
and
that's an image of fire.
Yeah, and here's flame. Okay, so what I'm saying, if you take a picture of fire, you get flame. Now, flame is flame in motion. Yes, it is. Okay, if you want to take it to the extreme, you're going to say yes. The question is, the word flame represents to one of the components of fire. Okay, and so in order to talk about fire in a static sense, or to point to whatever that thing is, we call it flame. And we say, hey, that image there, we'll call it flame. So you can say that flame is an object under that context. The context is very important, okay? So again, none of these words are scientific in the sense that make or break some important theory out there. I'm just trying to make sure that we understand that why plasma is an object, a concept, always a concept in the case of plasma. There's no ambiguity in the case of plasma. But people say, well, is steam an object? Well, are you talking about the gas that you took a photograph of steam of, or are you talking about this motion that's going on that you're heating this pot, in your stove? That's a different context. Now you're talking about something that's in motion, and usually, the word steam refers to this vapor that's moving, on top of your pot. That's what we call steam. Now, can you take a picture of steam? Yeah, but then what do you have? We'll call it gas. How's that? Okay, because steam usually refers to something in motion. So context is important. In the case of plasma, there is no ambiguity because the word plasma embodies motion because plasma means ionization, and ionization is already in motion. You have to put or subtract an electron. That's what ion means. Ion is not a thing. Ion is a process, and because it's defined as a process, and that's what people have trouble getting through their thick skulls. Okay, so someone also asked here, he says, science says kangaroo is an object, meaning rational science, right? He's saying that we're saying this, okay? Science says that kangaroo is an object until it is moving. Gas is an object unless we apply electric charge. And you almost got it, okay? Kangaroo and gas are objects, okay? And that should not be confused with what they do. When you say that a kangaroo jumps, a jumping kangaroo is not a physical object. A kangaroo is a physical object. And same with plasma. Plasma, here in fact I have a picture of that. Okay, so that picture's worth 1,000 words. Plasma jumping is a jumping kangaroo.
I mean, isn't it just, again, with all the words that you just went through, isn't it easier to just talk about water?
Yeah, and that's the point. You don't talk about
water
steam. If you're
jumping water.
Yeah. That's what steam is, jumping water. And same with this. You can see plasma has to be ionized. The gas has to be ionized because it's in the definition of the word. Please understand the context before one of us dies, okay?
It's jumping gas.
Yeah, but they don't understand. They say, well, gas is also moving. Yeah, gas moves. Yeah. I mean, it depends on the context. But gas, I can take a picture of gas. I showed this the other day. You take a picture of gas, blob, a cloud, a fog that's there, that's just sitting there. We call that gas. We use the word gas to refer to that image. You can't do that with plasma, because plasma, you take a snapshot of plasma and you say, is that plasma? Well, let's see, has in the picture, in the static picture, is the electron being coming in? Is the electron going out?
There's a ghost.
Yeah, I mean, people are
if you
totally
think
idiots
about it,
if they don't
most-
understand what I'm saying.
If you think
They have mental problems if you don't understand that plasma, you have to put or subtract an electron. That's part of the word plasma. You cannot extract that from the word plasma. And that's what you don't understand.
You're getting angry at dumb people, folks.
Yeah,
That's their problem. You shouldn't make it yours. But if you think about it,
It just drives you nuts that people don't understand
no, it
something
drives
so
you
simple.
nuts. It doesn't drive me nuts.
If
If you think about it, almost all pictures have gas in the picture.
I mean, if we're
They all
gonna,
have oxygen in
the
them.
first thing we have to understand is the following: the entire universe is moving. Every bit of matter in the universe is moving. I'm moving with respect to Jupiter right now. Every single atom.
Even
in my
if you're
body.
not moving,
Even if I'm not moving, I'm moving anyways,
Yeah.
whether I like it or not. So don't talk about that. Okay, don't use that as an argument. The question is, the definition of the word plasma already embodies ionization. Ionization is motion. You cannot extract motion from the word plasma. And that destroys the entire electric universe, especially because the word electricity is already something in motion.
Yeah,
the
it's
word
a verb.
electricity embodies motion.
Yeah.
So electricity is not an object. What does the idiot of the electric universe say? Well, Bill, why don't you put your fingers in an outlet and find out if it's an object? That's not the way we do it in science. In science, we have to define
That's
the word
like saying
object.
punch. That's like saying punch is a noun because it hurt. No, fucking fist hit you.
No, the issue here is the following. In science, you have to define the word object. If it meets the definition, it's an object. We don't run a test to find out if electricity is an object. But explain that to someone from the
I think they did. They ran that experiment many times. They fried their brains.
In fact, again, if you use the see, touch, and experiment, we cannot see or touch the object
no, but
that's
again,
on the other side of the universe.
According to the electric universe logic that you just used, punch would be an object because it hurt. But that's not true. It's the fist that
yeah, the fist is the object,
yeah.
not the.
The punch is the verb.
But explain that to these people.
I mean,
Okay,
this is
another fellow.
grammar. This is grammar.
Yeah, it's just they don't realize what they're saying. They just use these words without analyzing them. Okay, someone says light is something in motion, but you say light is an object. Yeah, we have to use the word light is an informal word. We use the word light informally. The object is known
Mother
as
Nature a lot too, which is kind of sketchy.
Right. I mean, but again, if you can't see through that, you got a problem. Okay. The issue here is the object is the rope, the electromagnetic rope. That's the object. Now you can see it's static there. We can take a snapshot of a rope, and that's a rope. Okay. Period. We're done. That's an object. It's got shape, etc. On the other hand, light, informal word light, is rope which is moving. In this case, torquing.
I guess light would be like plasma in that case.
Yeah,
It's
it is. But
jumping rope.
But sometimes we
Jumping
but
rope.
sometimes we replace the word rope with the word light. But hopefully you understand that that's in the course of
shorthand.
chatting. Yeah, it's shorthand. You can't say, oh, but you said light is a physical object. Well, the rope is the physical object. Okay.
I mean, technically, you could give the whole presentation without ever using the word light.
Yeah, but I mean,
you could talk about the electromagnetic rope torquing, and you technically.
But you get carried away in the discussion. You
Yeah,
know how it
obviously.
is. I mean, I use a lot of ordinary speech as well.
Yellow
Hopefully-
card. Yellow card.
You get a 1 instead of a 10. Okay, another fellow says, I thought the polarizing effect is caused by the molecules having the same orientation, which normally is only possible for a solid. He's talking about the fact that we did this experiment with Hans here, in fact, that we turned light around sideways.
What?
And, when we took the water.
We did that.
Yeah,
we moved the water. I didn't bend light. What?
Yeah, well, no, we bent water, okay. And so a fellow referring to this, he says, in a liquid or gas state, the molecules are continually rotating as well as moving. Are they? Are they rotating? Do we know this? Okay. But this is what he was taught, and he just repeats it, okay, because
It might be true.
It might be true, but he just repeats it, takes it for a fact, Okay, he doesn't even challenge that. He doesn't even question it. Okay, and this is where we have a problem. We'll see why. You would need a way to keep the molecules polarized in a liquid. Polarized? How about gravity? So people are thinking of electromagnetism. How about gravity? Does gravity pull on atoms? I mean, we have the whole Earth covered with air, right? Let's simplify. Let's say all of air is just two oxygen atoms, and they form this air molecule, O2. Okay, are those molecules oriented in any way with respect to the center of the Earth? Are they standing vertically? One oxygen on top of the other oxygen, or are they symmetrical with respect to the edge of the Earth?
I mean, standing on its head is also symmetrical.
Yeah, it is in a way, but tell me which way is that oxygen molecule pointing, or is it just twirling around?
I think it's just twirling.
Okay, but this is what we have to. This issue is not settled. We need to discuss it. Yeah. Okay, these people just memorize in college, and they say, "Oh, this is what I learned."
Well, I mean, you have to take something for granted.
No, we don't take anything for granted.
You
got to
start somewhere.
From quantum mechanics to general relativity, we don't take anything for granted. Oh, you would need a way to keep the molecules polarized, it says, such as by generating an electric field. What is a field? What is an electric field? We have no idea. There's no physical object called an electric field. Okay. Field is a concept, means a bunch of numbers. That's all it means. Around a liquid whose molecules are dipoles. Okay, so the question is, do molecules in a fluid obey gravity? Can gravity affect any molecule out there, like air or water?
You're saying there's a difference between, you want to make the distinction between just being pulled by gravity and being oriented by gravity.
Or by, one is by gravity. What these people are referring to, what they learned in college by rote, is that electromagnetism. They're not even considering gravity at all. They never introduced gravity in the context of a molecule.
Yeah.
So they're just talking about, well, you have this electric field, the magnetic field, you have the electromagnetic field, influence this molecule, and here it is in a solid, here it is in a liquid, here it is in a gas. That's all they can think of. It never occurred to them that maybe gravity does affect a molecule. Okay, and that's what we're getting into here. We're going to challenge this fellow, okay, and what he learned by rote in college. Okay, so here it is. Here we have, let's go step by step, okay. Here we have my son, and he's going to turn that water around. And the question is, when you turn a piece of cardboard around, the molecules, rotate together with your hand. The question is if that happened also with the water in there, okay? And let's look at a similar, related scenario. Here we have the same picture, okay? But we're going to leave water just standing still for 3-4 days, okay? On the table, for example, right? Here I just kind of illustrated it here. Does water move?
What do you mean?
Do all these molecules, is there turbulence inside that water? If I leave a can of water or a bottle of water or a cup of water on the table for 10 days, no one moves anything anywhere nearby it. Do those water molecules, are they in a turbulence? Do we have waves in there? Are the atoms or the molecules moving around? Are they drifting? Are they
Depends on what
twirling?
you're talking. Now we have to be specific because they are moving, but you're talking about waves. That's a big distinction. They're not making waves clearly, but they are vibrating because all atoms vibrate.
Okay, but
what motion are we talking about specifically?
Okay, now we're going to look at the motion that we're talking about. Okay, so you got the question. Hopefully you understand the question. The question is whether there is turbulence in the water that I left for 10 days just sitting there. We have calm water. We have no waves, no anything that we can see at least,
Here's a better way of asking that question. The water molecule on all the way to the right that's almost touching my palm there in the picture. Does that one let's say touching the glass, this near my palm, does that one ever migrate to the left side?
Yeah, does that is that water moving? Do we have a river there?
Is there a current?
Even if it's is there a current? Is there a river? Is there a motion there at all, or are all those?
Yeah, motion. I don't like saying motion because there is motion, but we're talking about specifically the grand motion.
Especially, how are the water molecules oriented?
Yeah.
Okay, what is
With
the
respect,
tilt
yeah.
of the water molecule? That's what I'm getting at. Okay, tilt. Okay, that's the level that we're talking about here. Okay, let's look at an example here. Here's the water molecule. Okay, let's go slowly, one step at a time. Here's a water molecule. We have 2 hydrogens and 1 oxygen. Okay, let's assume, and again under the rope model, for those of you who are interested, oxygen is comprised of 8 hydrogen atoms. That's how the sun or the star, whatever, squashed or had to squash 4 hydrogen
8.
atoms, 8 hydrogen atoms to make that oxygen atom, okay, that element. Okay, so we have 2 hydrogens, 1 oxygen. Since it's got more ropes, I'm going to position it arbitrarily, not that I know, but I'm just going to position it arbitrarily with respect to the center of the Earth in that direction. Okay?
You're saying the center of the Earth is down here.
Yeah, in other words, under this scenario, not that I know, I'm just going to do it arbitrarily, okay? Just hopefully nobody shoots that in my face. Okay, I'm going to say that the molecule is oriented like Mickey Mouse's head. Okay, we have his chin at the bottom, the ears at the top. Okay, we got that so far? Okay, let's move slowly. Now, I'm going to turn, what did you do? You turned the glass around, right? Rotated it 90 degrees, right? Okay, now here's the $1,000,000 question. Is that what happened to the water molecule? Did you turn the water molecule to 90 degrees? Or did you leave it in the direction that you see on the left? Did it stay in that position or did it move around? Okay, let's look at several water molecules so that we know what we're talking about. Once again, here it is. Okay, this is one scenario and this is a second scenario. Which one is it? And if you look carefully, the red ones are the oxygen. Okay, and in the case of the one on the right, it's always pointing towards the center of the Earth because of gravity. Not because of electromagnetism, but because of gravity. What is gravity? Under the rope model, it's 8 ropes being tugged or being connected to the center of the Earth. Okay? So which one of those is happening when you turn the water flask or whatever 90 degrees?
Well, we did the experiment.
Is the water
experiment, so we should know, right?
Oh, we do know.
I mean, isn't that how experiments work? We proved one of these. I just don't know which one it is.
Okay, so those are the 2 scenarios, and the question is, it's got nothing to do with electromagnetism, at least as far as I'm concerned. I mean, it could, but I'm going to leave that part out. I'm just saying, let's look at gravity, only gravity. Does gravity affect the molecule? Does gravity maintain the tilt of the molecules? Okay, that's the question before you. Okay, and so that's one thing you got to ponder. Let's move on and look at now oxygen. We're looking at air now. Here's the air molecule. Okay, 2 oxygen atoms. Okay, we got that? Very easy.
Dumbbell.
It's a dumbbell. Yeah. Question is, does it do this? Does it stand on its head? Okay, let's remove this. Does it do that when you turn the balloon around? The balloon is full of air, you turn it around. Does the air do that inside? Does the oxygen molecule, stand on its head? That's the question before you. And the issue here is, does gravity affect that molecule? Okay? And so here we have a bunch of molecules of air. Which of these is the case? Does it go from horizontal to vertical, or does it always stay horizontal? That's the question for you, and the issue is gravity. Okay, let's forget momentarily at least with electromagnetism. Okay, so those are the questions before you, and the issue is that nobody has ever asked these questions in the history of so-called physics. Okay, no one has asked these questions, and so now we're asking the question. That's why we don't take for granted what they teach in college.
I mean, it's not even that. No, again, like you said, no one even asked the question, so there's no answer for it. Even in mainstream, they couldn't. They were never high enough to ask that question.
Yeah, and why do we ask the question? We ask the question because we're saying that every atom is connected with ropes, electromagnetic ropes, very thin, very tiny ropes that are connected from atom to atom. And now you're saying, okay, if you have this water molecule, for example, water molecule, okay, and the oxygen is tied by 8 ropes to whatever atoms are in the center of the earth, to each one of those atoms, right? 8 robes to each one of those, right? When you turn that floating molecule around, remember there are other molecules sitting on or hitting its elbow. We discussed that the other day, hitting its elbow against other molecules. Does it maintain, or do they all maintain the same location with respect to the center of the earth, or do they tilt 90 degrees?
Yeah, I made the distinction between water and air in this case because with water, it has the Mickey Mouse ears, so it has more, I thought of it more like a buoyancy issue. It's more of a density issue where the the hydrogen ones can't go past the oxygen one, so it can't really push past the neighboring oxygen molecule atoms. But with oxygen, like just air, if it's just two O's, there's no buoyancy issue since they're both the same weight. The density doesn't play a part, so it's just turbulent. It doesn't matter. If you turn the balloon, it does turn. But with water, I think the buoyancy keeps the hydrogens on top.
The only issue I've got there is that they're both pulled by 8 ropes. If you pull one down, does that one beat the other one? It's like violating Galileo. Galileo says all objects fall at the same rate to the center of the earth. Now we know why. They're all tugged by ropes, or they're all connected by ropes. And so the question is, can you have one atom of the air molecule pull more than the other one?
I think it does because again, it already fell as much as it could. It's suspended. It's held in place by the other oxygens, and just turned.
My answer to you is food for thought. Yeah. That's something you got to ponder.
We definitely had thought about this for a while.
We discussed it quite a while, but I don't think we reached an agreement.
I did.
Or we
agreement, no, but I won.
Well, but you're wrong. Yeah. Okay, another issue. Okay. I just wanted to show that you have air, first water, and then air around the planet. Okay, I showed this the other day. And the question is, do they maintain that position all around the earth? Okay, and I'm saying that they do, or
I'm saying
but I'm suggesting that they do because they're all connected by ropes. Okay, and
I'm suggesting the hydrogens ones are correct, but the oxygen ones aren't.
Oh, yeah.
That's what I'm saying.
You have something against oxygen. That's your problem.
Yeah.
Okay, anyways, those are things to ponder, okay, especially for flat earthers who don't understand why water curves around the earth. Well, there you see why it curves. They're all the water molecules are connected by ropes to the center of the earth. Yeah. So that's the issue. Okay, another issue, moving on here, quantity. Someone says, I don't know why it always goes that. Okay, is a quantity not then a quality, magnitude of a physical object? An adjective describing the object.
You're saying the 3 apples, the threeness, the magnitude of 3 would be
an adjective.
A quality of the apples themselves.
In ordinary speech,
even there it is.
Quantity is a noun. Okay.
Yeah, but even there it is.
And he's saying, well, we're using it as an adjective because we're qualifying objects, not object. Yeah. But objects, because when you talk about quantity, you're talking about objects, plural, right? And the issue is quantity is an adverb. It's not a noun for physics, not ordinary speech, not mathematics. Yeah. We're talking about physics. Physics, quantity is an adverb. Why? Because it has to do with the word number. What is number? It's the verb to count. And here we've illustrated it so you know what the verb to count is. There it is. It's when you move your finger many times, you give it a name. If you move it once, you call it a 1. If you move it 2, you call it a 2. And that's what number is. Number
I feel like you're being patronizing right now. I mean, that's one way to describe it, yeah.
Okay, so number is how many times you move your hand.
You give
a name to each.
You give each direction of your finger a name. That guy's called 3, that guy's called 4.
Right, and that's what a number is. Okay, number is a verb. And so number is a verb and quantity qualifies some object, then we're saying is quantity is an adverb. That's why it's an adverb. Okay, the quantity does not qualify one object. In fact, it has to do with counting. Okay, counting is a verb. Okay, so all these things we have to look at the context. Again, you have to learn the language of physics, and that's different than the language of mathematics. First, the nonsense that everyone from Newton to Stephen Hawking, created. All that nonsense. That wording is of no use in physics. Okay, in physics we use a different language because we're going to give a physical interpretation. That's what science is about. Science is not math. Science is not making predictions. Science is not using words like field and force and mass and energy. Those are not scientific words. Science, we deal with physics, right? We deal with objects. You can't do physics without an object, so you need to define the word object and all the words that are important within that, within the foundations of physics. Okay, so a fellow says, we can't define black, therefore black is an object, because I'm saying that if you can define it, it's a concept. In science or in physics, we point to objects, okay? And so I'm saying, well, yeah, we can define the word black. And you look up the word black, it says, a color that lacks hue and brightness and absorbs light without reflecting any of the rays composing it. Black means no frequency, okay? It's the absence of light. It's, you can say, the color of space.
Isn't
because
that a
space,
verb?
no.
Isn't black
Remember,
a verb?
no, it's not. Not
It's an adverb. It's
no,
how.
not in the case of black, but that black is an exception. Let me
What?
show you why.
Uh-oh.
It's an exception. Yeah, let me show you why. It's the only color that's an exception by definition.
Uh-oh.
Why? Because the word black refers to space. It's the absence of light. That means it's the absence of anything. What we're talking about is space. So black is a color of nothing.
Black
Okay?
is black.
Yeah, black is black. It's the color of nothing. Now let's get to another color that this fellow raised. He says yellow. Okay, now we're getting to colors, to real colors, right? Okay, so he says people doing the stream told me yellow was a concept, but couldn't define it. I said yellow was an object and pointed to it like so. He said because you can point to it, right? That's what he's saying. A couple guys answered him, says colors are processes, much like a tornado or plasma. Yeah. They are nothing more than the flow of what? Lengths of the rope at particular frequencies. Okay, listen to what the guy said. He's got it right there, okay? Another guy pointed out, he says, object, that which has shape, nothing to do with pointing. Okay, so let's clarify this. Let's make sure we understand what the issue is here. Okay, let's first address this pointing issue. Okay, pointing is an observer-related phenomena, okay? But in mathematical physics, an observer is a witness. That what they want to do is introduce testimony in the religion of math. Okay? In physics, we don't do that. We don't accept witnesses. Okay? No observers allowed. The theorist points, in that sense, he's an observer, you can say, but not to present his testimony. He's presenting an object, and that should not be confused with giving testimony, witnessing. The theorist names an object so the crowd can follow the presentation. Okay? And there we have the word object is that which has shape, as this fellow said there. Concept, a word that invokes or embodies two objects. You need a relation between two objects, and that's what we call a concept. You must define the word object before you define the word concept, because you need two objects to define the word concept. And you must define distance, location, before you define motion or exist, because they depend on those two words.
I think a big problem with a lot of what you talk about, Post, is
Yeah.
You're talking about the rules of
The foundations.
But the rules of giving a presentation is the bottom line
Exactly.
of what we're talking about.
And that's what physics is.
But
We're
but
trying to understand.
But
Explain and understand.
But there's not a lot of people giving presentations. It's like,
Well, the
you talk about
presentations
the
they
rules
give
of-
are nonsense
Yeah,
because
yeah,
they're trying
no.
to give up. What do people at Quora, where people ask questions, what do they ask? What does the common man out there on the street want to ask? If you say, look, here we have two magnets, right? And they pull each one pulls the other one. And so the common man out there, he doesn't want to know math. He doesn't want an equation. He said, well, how does it do it? How does Mother Nature do this magic trick? Or you have a simpler one. You let go of the pen or a pencil and it falls to the floor. Why does it always fall to the floor, not to the ceiling? That's what he wants to know. He wants to know straight stuff. And for them, for the common man, that's physics. He wants to know the process, the mechanism. And these guys come out and say, well, you got to take a course in math to understand this. Oh, math? Why math? Well, see, because you have the force and the mass and the energy and what's that got to do with anything? I'm asking you.
Stuff?
Yeah, all you need to do is identify the physical object that came in contact with the skin of the pen. That's how simple it is. That's what the common man wants to know, and that's what he understands by physics. And what the mathematicians have done is that, well, we don't understand any of that because we can't see the invisible things, so we don't think there are any invisible things there because we can't see or touch them. So all they do is math. Okay, all they do is mathematics. And they equated science, so-called physics, right, with mathematics. And they say physics, the language of physics is math. That's what they say. And this is a problem because no, the language of physics is illustration. You need to illustrate the mechanism. Otherwise, you're not doing physics, you're doing math. And that's what we have today, just a bunch of math and irrational explanation.
Funny enough, there was a celebrity, I can't remember who it was. They asked, I think, Neil deGrasse Tyson if math had anything to do with science, and everyone laughed at her. I just thought it was like, it's taken so for granted that it's like, ugh, this poor dumbass doesn't even know what she's asking.
Okay, let me explain the last part of yellow.
You really need to know math to know why the pen went to the ground.
Okay, here we have yellow. Is yellow an object? Well, the guy kind of was playing devil's advocate, but there's nothing wrong with that. That's okay. I have no problem with people playing devil's advocate. Okay, so if that was his intention, that's just fine. No problem. Staring at a wall, not at yellow. That's what you're staring at. Okay, you're not staring at yellow. Okay, you're staring at an object that is yellow. What is yellow? Yellow is a comparison.
Again, isn't
you wouldn't have? Okay,
I
let
was
me
saying
go
earlier about black. Aren't colors adverbs because it qualifies the speed at which the rope is
frequency?
Torquing. Yeah,
but all of them except black, because black is the absence of rope. Black is space, nothing. That's black.
But that's not exactly true because you could have a black cardboard and that's
no,
not space.
that's not pure black. It's like they took black hairs of black men in Africa and they took black hairs of men in Japan, and they say the true black, or the blackest black, is the guy in Japan, not the guy in. Unbelievable. I thought it would be the other way around. No.
You're saying space is blacker than a Japanese guy's hair.
You got it. Because it has no color. So black is a special color if we're going to go very technical.
If you can call it a color.
Yeah, if you can call it a color, okay? But staring at the wall, not at yellow, okay? That's the first one. The wall is the object, yellow is the adjective, okay? In this case, it's an adverb, okay? Because we use it to qualify the wall, but at the same time, yellow is what? A frequency. So we're talking about motion here, okay? And there you have it. Adjective is a qualifier of a noun, okay? And there's no standalone object called yellow, okay, obviously. In quantum mechanics, yellow is a frequency, okay? In fact, it is so also for the rope model. And yellow is 580 nanometers. That's the wavelength, or the link length in the case of the rope model. That's a static concept. But when you talk about frequency...
Static concept?
Yeah, in other words, nothing is moving when you say this is the link of a rope.
You mean you could take a picture of it?
Yeah, I can take a picture of a link. In other words, that's all. We're talking about how long it is, okay, in that sense. But then it says, in the case of quantum, it talks about 5.16, 10 to the 14th hertz. Okay, that's the frequency. Supposedly, little beads moving through the detector. And that's the frequency of yellow. So yellow is something in motion. That's my point, okay? Yellow is a comparison because you wouldn't have yellow unless you had blue and red and other colors. If everything in the universe were yellow, we wouldn't have the word yellow. We wouldn't even have the word color, okay? So that's something else you got to think about, okay? That's not the case with objects, okay? Unless there's a single object in the universe, then you wouldn't need the word object, okay? And we say yellow is not independent. Meaning that in the case of yellow, it requires other colors. Otherwise, we wouldn't have a need for the word yellow. In the same way, a halo requires an angel, because without the angel, all you have is a ring or a plate. And magnetic field requires a magnet, because otherwise you don't have a magnetic field. In that sense, these are all dependent objects. Therefore, they're not objects because they are dependent. An object is independent. You know, a
like,
circle is an object. Yeah, I know that hurts people in
would
the ears, but a
flame-
circle is an object because I don't need another object in the field of view. I can put a circle all alone and I don't need to have any other objects. And I call that specific pattern, you know, I call it a circle. I don't need to have a square. I need a square to compare the word circle against the word square, but I can point to a circle without need for triangles or squares. Okay, in that sense, it's an independent object.
I mean, can't you point at yellow without the color red next to it?
Yeah, but if yellow is the only color in the universe, then you know, then I would not need the word yellow. Okay?
Whereas with circle, with circle, if you had two circles, now you can have two yellows. They're both yellow, but with two circles, it's circle A and circle B, I guess.
No. The question, the issue I'm trying to address here is that I can have a circle. That's all that God made in the universe. He made a circle, and He made it two-dimensional, and it's got no. He didn't put it against paper. He didn't put it against anything. He just made a circle in the middle of space. That's how powerful God is. Okay. Now He made a circle there. Do I need a square? Do I need a triangle? No. He calls that a circle. He could have called it X. I see an object there. It stands alone. We refer to that object, that specific object, as circle. We could call it X. We could call it Y. It doesn't matter. He called it circle. Fine. So we call it circle.
We're getting really abstract.
Yeah, but the point is, I don't need the word square. I don't need the word triangle. That's not the case with the word halo of an angel. I do need the angel because otherwise all I have is a ring, not a halo or a plate. Do I get through?
Going back to black, I still don't like calling space black. Is it more accurate to call to say it doesn't have color than saying that it's black? Because black is what you said. It's a low frequency. It's a Japanese guy's hair, a black hair Japanese.
But then, if you're going to go with that argument, then you got the issue is tell me what the frequency of black is. Okay. What is, you're saying that here you have a rope. I mean, you have white light. What is light? White light? Well, it's a mixture of many lights of different colors.
It's a low frequency.
Is that? Well, yeah, okay, you could do that.
Because
okay, I guess you could
if it has zero frequency, that means it's not a rope. That means that's space.
Okay, but then it's like, you know, you got 620 nanometers, that's red, right? And if you got 625, well, you don't have red anymore. Now you have orange.
Exactly.
Maybe. Okay, but now, is black black? Black is black? I don't know.
Yeah,
is black black?
There's different shades of black. There's different frequencies.
And so the question, what is the exact frequency of black space?
No, that's incorrect.
Oh.
Space has no color.
Correct, and no color is black.
No, that's not true.
Okay, I see.
Air isn't black.
Air is not what we're talking about.
Yeah, but air has no color. That's not black.
Okay, well, we got to debate that.
No, we debated it now. I won. That's just logic.
Okay, last issue before we open the floor. Well, otherwise, it's going to take all day here. Experiment is very much part of science, the fellow says. It is the largest part of the scientific method. There is no wave theory or particle theory. There is a wave-particle theory. There is no wave theory, no particle theory, but there's a wave-particle theory, okay? Which has experiments that back it up. That is what makes it a theory. No, a theory is an explanation, not the evidence that you present to convince people. Okay, so science is not about persuading and convincing, which is what you're talking about there, backing it up. Backing it up is evidence. It means you're going to present evidence to the jury to persuade them to believe in your theory. Belief in a theory is not explaining a theory so that you understand it. So one is objective, the other one is subjective. And the subjective one belongs to religion.
Are we going with questions? I didn't see that many, but there were some good ones.
Go up there and see.
Let me go scroll through the comments here.
Okay, what do we have?
Hello, cheers. Survival of the random, is that better than survival of the fittest?
No, I'm saying we shouldn't qualify. We should not qualify things in success and survival of the fittest. I don't think we need those in science, okay? People can have their opinions, but the issue is Those words only interfere in science.
Has anyone come up with the definition of yellow? After that, a lot of people in the chat wrote the nanometer wavelengths.
Yeah, I mean, yellow is just a frequency, okay? Just the synthesizing, right? Making it short. So yellow is a frequency. Yellow is a comparison. You need other colors, otherwise we wouldn't have the word yellow at all. And a yellow obviously is a qualifier of the wall. The wall is the physical object. Yellow is what it is. It's like saying the wall is big. Well, the wall is big. Is big a physical object, or are we comparing big against little? You know, that sort of thing. So yellow is obviously a relation. It's not a standalone physical object.
Is reality an object?
No, reality is an object that has location. Reality is a synonym of exist, and exist is defined as an object that has location. Now, you talk about reality, like my reality, you're talking about...
yeah, it depends on which
ordinary,
reality we're talking about.
You're talking about the ordinary speech version. We don't use that word in science. There is no such thing as reality in science.
There's no such thing as reality.
No, not in science. In science,
scientists care about reality.
Yeah. Reality means that your state of mind. What is your reality? That's where that's ordinary speech. In science, in physics, physics is the science of reality. In other words, existence.
You're saying we don't care about reality in physics, but
it's the science of existence, meaning we have to define the word exist, which is a synonym of the word real, not reality, but real. Yeah, what are we talking about? We're saying that. We have to define this term.
I guess
exist means an object that has location.
I guess with reality they mean all that is in existence.
Yeah, but I mean
that would be a synonym for the universe, if anything.
Except that when we talk about all that exists, we call it matter.
Yeah, that's a synonym.
That's the word. Yeah,
it's a synonym.
You could say that
reality, matter, universe.
But see, the word reality has a different connotation.
Yeah.
So
it's
you gotta
more
be careful.
Subjective. Like my reality, your reality. If I take shrooms, I have a very different reality.
And we're talking about your feelings, not really what's real in physics.
Reality is also mixed up with consciousness.
Yeah. So we forget about the word reality completely.
You could use it, but it's just counterproductive.
I don't use the word conscience. I don't use the word reality. Those are foul four-letter words.
Organization, pop. Skimming through. I'm looking for question marks. Is your idea that molecules in fluids do not rotate, jiggle, etc., like billiard balls bouncing around, classical study of gases teaches?
Well, molecules do, as you said here, my good old son, he said they vibrate, okay? Remember, the atom is pumping, okay? It's doing its quantum jump, and it's torquing the ropes. It's being also influenced from outside, what we call electromagnetic influence, right? We have other atoms influencing it either through light or through touch, okay? Through the rope.
There's a lot of motion going on.
Yeah, there's a lot of motions going on. So the molecules, any molecule, even the ones that are in steel, stainless steel, they vibrate, okay? So there is motion always, okay? What I'm talking about is here you have a loose molecule, such as air or water, okay? More or less, it's not tied to a crystal lattice. That's what I'm saying. So now this molecule not only vibrates and jiggles and does all its quantum jump and all this kind of stuff, but now the question is that molecule is tied to the center of the Earth, here on Earth at least, right? It's tied to the center of the Earth. Does that molecule, when you turn it around, one that belongs to a fluid, or to a gas, right? When you turn it around, does it stand at 90 degrees to where it was before? Or does it maintain its tilt, its orientation with respect to the center of the Earth? That's the question, okay, that we have to answer. Okay, I hope
I guess you didn't really answer any questions. You asked more. You're the one asking questions.
I'm
the one asking the questions around here.
I'm answering with a question because that's what we need to figure out. Does that molecule rotate or not? If it's a fluid or, gas or water or whatever.
I'm not sure I understand it, but I'm just going to read it.
Okay.
Rationality forbids creationism plus destructionism. I guess that an atom can come in from nothing,
Yeah,
and
yeah.
and nothing can become an atom. In a universe with only two tangible parentheses cubes set to collide, would they halt or bounce? I think they would just stick together, wouldn't they?
If cubes are, well,
In a
that's a strange situation because what we're talking about is a very hypothetical situation, right? Where you say, look, you have two cubes. What set them in motion, first of all? Okay, that's the first thing we have to try to figure out. Okay, and you're saying they're coming towards each other, and the question is, are we talking about these cubes made of a single piece each, or are they made of parts? Because they're made of parts, we can't talk about the cubes. We have to talk about the parts that make the cube
I think
and why they're coming together. And if they're made of atoms, for example, are they connected by ropes? So there's a lot of questions there.
I think there's a follow-up question here.
Okay, but let's assume for a second we have two cubes. Okay, they're made of a single piece. They're connected by a single rope. Okay, that's I have to make some assumptions here on your question. And so the question is, first of all, why would they come together? Why would they rotate? Okay, so you got to explain
rotate
the origin of motion.
Yeah, well, not, I mean, rotate in that case in respect to what?
Right, because Mach's principle says that everything is interconnected. So when you twirl around, you're pulling against all the stars. Okay, with a rope model, we can understand that. With quantum and relativity, no way you can figure that out because you need to put concepts in there. You can't figure it out the physical mechanism. But then the question is, if you have two cubes tied by a single rope and they're both made of a single piece, do they rotate? Do they come together? What set them in motion?
Come together.
And then even if they come together and they hit, what they're under the rope model, they're eating into the rope. Okay? And so the question is, are these cubes elastic or inelastic? And so you got a lot of questions here. It's not a simple question to ask because we need to know all the little details of your presentation of your...
The intangible rope has a little bit of friction. This halts motion to a degree, doesn't it? The intangible rope has a little bit of friction. This halts motion to a degree, doesn't it?
Well, that's a very important issue. What we're saying is remember the atom eats into the rope because the rope makes up the atom.
Well, eats into it and spits it out.
Yeah, the question is how much friction does it, or does it swallow the slack and spit it out the back end when an atom moves through the rope? Okay, so is there friction? I don't know if we can talk about friction when we're doing that. Okay, because the atom is sliding through the rope and the rope is going through the atom, going to the next atom.
Now here's a follow-up to that.
Yeah.
Shouldn't processes like magnetism and the rope crossing over itself in general cause the universe to one day grind to a halt? But I think we answered that with the fact that the motion always goes somewhere. It's the metaphor we came up with the ball of water in space. A moving ball of water in space has nowhere to pass that motion onto, so it's not rubbing against the fabric of space or anything. Right. There's no loss of energy. Energy doesn't go anywhere. I guess it's the same thing with creationism and destructionism. There's no loss of energy. It's always just going somewhere else.
And anyways, beginning matter, beginning motion is out of the question, and in the same way, ending motion and ending matter, so that matter turns into space, that's out of the question as well. I think so there's no creationism in the sense of something appearing from nothing, and there's no destruction in the sense of disintegration where matter turns into space. That's my point.
I think that the question is also answered by the fact that if we assume that the universe, as in the matter in the universe, is eternal and is in motion, then it has always been in motion, always will be in motion.
Correct. That's the way I look at it.
That's a cleaner one.
I cannot imagine the beginning of motion and the end of motion. I cannot imagine the beginning of matter and the end of matter. But if you can imagine it, please explain the process.
Hi, Bill. Can you make a thesaurus for your foundation of physics? The old one is hard to find and has several broken links. Love the show.
Huh? Make a... I do have foundations of physics. There's not that many words. All we need is 10, 15 words that you need as foundations for physics. So it's not like you have a thesaurus. It's like a little glossary. That's all it is. And essentially, I pointed out some of these words. You can find them in my website also, youstupidrelativist.com. It's look under, what is it? I think it's glossary. At the bottom of the page, you'll find a link there for glossary. It gives you a whole bunch of words. No, there's a better one there. In there, I put the foundations of physics. You got to look at foundations of physics includes the important words that form the foundations. So we don't need a thesaurus. It's just a glossary of maybe 10 to 15 words. I can't remember how many of them.
Question for Bill. How did you get from light being a rope to those ropes connecting all objects in the universe? And how did you get from that to them being gravitation?
Well, let's go with the first question. The first question is, when you follow the rope, it ends in an atom. When you follow that atom, it ends in a rope, and so on down the line. And you have to say, at some point, you got to say, well, where does it end? I mean, is it like the mathematicians like to use that word, infinite? And the answer is no. And I'm saying no. If it's not infinite, it's a circle, which is one of the issues that mathematicians bring up. And yeah, if you have a circle, what you're talking about is a thread, which looks more or less like this, like a rubber band. It's a closed loop circle. Okay, that's how I ended up with I started with a rope. I ended up with a thread. And what was the second part of that question?
And how did you get from that to them being gravitation?
Well, what's interesting, I discovered gravity first. I discovered that in November '97. And I said, look, and I did it with lines. I did not know anything about the rope at the time. So I did it with lines. I said, well, when an object approaches another one, you can imagine all these lines. If the two objects are far apart and you have lines connecting every one of their atoms, and then if you put them closer together, they open up. And so I figured out gravity was simply a question, acceleration of gravity, just how close and how far an object is from another. Then a few months later, in January of '98, I came up with a rope model, not the rope model, but I was getting close to it. And until February, I really came up with the idea of one day I came up and said, we have this rope. I was looking at waves, and I essentially replaced the wave with a rope. And that's when I finally made the connection. I said, hold it. If every atom is connected to all other atoms, and here I had the idea of gravity, that all atoms were interconnected by these lines, I'm just going to replace the lines with the ropes. And that's how the theory came together. The grand unified theory came together.
Under what authority do you announce yourself as a scientist in this irrational non-science nonsense? Folks?
Well, I got a PhD degree from Harvard University.
Oh shit! Really?
Yeah, PhD stands for phony degree.
I thought it was a pretty huge dick.
And everybody who's got a PhD knows it stands for phony degree because obviously they cannot explain a single phenomena out there. Okay, so no, we don't use authority in science.
They can do math good though.
we don't care about degrees. Okay, in science we do not start by saying, "Oh, I'm a PhD. I have a master's degree in."
You should start all your shows from now on with that.
No, the way we do it in science, we say, it's like I always give the example. You have here the world champ the world boxing champ, the heavyweight boxing champ of the world. He walks down the street. And he finds this guy out there, and they start arguing. And so they say, okay, let's fight. Let's resolve this like men. And the champ says, do you have a degree in boxing? And the other guy said, well, we'll find out when one man remains standing. And it turns out this guy out of nowhere.
That's the scariest threat ever.
This guy.
We're about to find out, aren't we?
And so,
both of us.
And it turns out the little guy, this unknown guy, beats the crap out of the champ of the world. So, forget about authority. It's you got to listen to what people say, what the arguments are, what they can explain. And right now we have no explanation whatsoever from people who have big degrees from the biggest universities on the planet. So much for PhDs and and degrees and big universities, Ivy League colleges, Harvard, Cambridge, Oxford.
Bill,
They cannot explain anything.
that question about the water molecule rotating
Uh-huh.
when it is standing still on Earth's surface can easily be answered if the Earth doesn't rotate, can it not?
We had a big talk with this gentleman here, about the influence of other molecules.
It's funny
And
how quiet I am on the show,
yeah.
but in the kitchen, I don't shut up.
Well, we came up with a different scenario similar to yours, but this was the scenario we came up with. We said, what if God, right? Here's all powerful God, and he made a single molecule, okay? And he put it,
Water molecule.
forget about the earth because we're polluted by all this air that's around us. No, he puts it on the moon where there's hardly any gravity and there's no air, no nothing, okay? Or you have a little bit of,
there were none.
yeah, we're going to assume there's nothing there. And he puts a molecule there, molecule of water or molecule of air, okay? And the issue is that we came up with is that there's no other influence other than gravity, right? And so the question is, does it depend on how God positioned the molecule to begin with? I mean, if he positions it standing upright or sideways, is that how it's going to stay with respect to the moon? And keep in mind Galileo's test that, he said that the way he explained it, he says, you got two rocks tied by a stone, okay?
No, tied by a rope.
Okay, whatever. And so you drop them, and one stone will not go faster than the other stone. And so now you have this molecule that you created on the moon. They're tied by a rope, right? It could be water, it could be O2, okay? And the question is it the way God put them originally, or will they realign itself with respect to the moon based on how many ropes are connecting each one of the atoms that comprise the molecule? And so we had all these discussions, very detailed discussions.
In my mind, I was thinking if you put the water molecule, the Mickey Mouse ears, and you put it like perfectly up, like vertical, like where the hydrogen atoms are perpendicular, then it wouldn't fall over. But if God put it tilted, then it would tilt over and fall. As if you had a basketball with two tennis balls and you just put it there, it would fall to one side.
But let me tell you what the issue was. The issue was, again, here's the test. If you put some water in a tub, whatever, and you leave it sitting there for 10 days, whatever, until it's completely still, okay? Do the water molecules, listen to the question, do the water molecules point all in the same direction towards the center of the earth? Have they all jiggled, aligned themselves in such a way that they finally stabilize so that, for example, the oxygens are all pointing towards the center of the earth? That's the question. And what Hans was saying, well, it depends on the molecules that are next to it, the ones that they're elbowing against. And you cannot create a scenario where you have, like in space, you have no container. Okay, so now we have all these water molecules. You take an astronaut, he takes a balloon full of water. He pops the balloon, now you have this blob, okay? It's just floating in air, but we're assuming he's in the middle of between two galaxies. No matter, no nothing there, okay? Do those water molecules align in a certain way or not? Are they all tilted in the same direction, or are they just twirling around in any old way? And now we go one step further. Those molecules approach another galaxy. Now we have gravity. Will they all align themselves? And what you have to keep in mind there is, if they align themselves, that means one part is moving faster than another. Yeah, and that's forbidden by Mr. Galileo. So keep all these issues in mind. We discussed this in great detail, but so far we're still debating.
The jury's out.
The jury's still out.
Okay, two cubes, each of a single piece. Okay. They are tangible and the only things that exist, no rope. They were always moving. Now they are about to collide. Do they stop, stick to each other, or do they bounce?
I don't know.
I mean, without the rope, now we have a different scenario.
Well, you're saying two
There's,
cubes.
there's no
rope.
there's no reason
They're already moving. I mean,
I think they would bounce because there's no reason they would stick to each other without the rope.
well, the question here is, are they elastic or inelastic? That's the
inelastic issue. Was. I think,
yeah, but I mean, okay, that's what we're comparing. We're comparing whether they're going to stick together, okay, meaning inelastic, and whether they bounce, meaning they're elastic, okay. And the question there is, what material are they made of? You're saying they're made of a single piece. Well, the question again is that material elastic or inelastic? And that's a question of a definition. In other words, you do the test, okay, and then after the test is finished, you say, oh, they bounced, we're going to call that elastic. Oh, they stuck together, we'll call it inelastic. So it works the other way around. The test, you're trying to define the word elastic, and you're trying to define the word inelastic, and you define it based on the results of your experiment. It doesn't work the other way around, saying, let me predict. Okay, we can't predict. Okay, not in the scenario that you're putting up, that you're presenting. What you're saying is the opposite. You're saying you're trying to define the word elastic, you're trying to define the word inelastic with your so-called experiment.
Does a spring compression / tension violate rationality when it begins to move, quote unquote, out of nowhere when let go? Not like the fingers squeezing, stretching it, pushed it into motion when let go. You just kind of let go and it moves on its own.
Well, you've got it under tension. You know, you're compressing against its nature. Its nature is to be, uncoiled, and you try to coil it like a slinky. You're pressing it, and it's going to tend to push out. I mean, I don't know what the issue is here.
The spring pulls, pushes on itself. What's that about? Balance forces equals no motion?
Well, for that, you got to go at the molecular level. Forget about talking about forces and all this mathematical nonsense. You got to look at the molecular level, what's happening to the molecules that make up the spring. That's what you got to look at. I mean, are we talking about a fluid? Are we talking about a solid? That's what you got to look at. You got to look at the crystal structure to answer that question. Okay, so, this is the issue.
If the bowl of water is sitting on a table for a day, I feel like those like rabbis that play chess and ask those really deep questions. If the bowl of water is sitting on a table for a day,
yeah,
then by your model, they would have to do a full 360 turn, thereby agitating the water. So by your own theory, the Earth is stationary. Agree?
I don't know where you got all that. I mean, don't put words in my mouth.
The molecules wouldn't. I think as he's saying, the Earth is turning, so it's turning the molecule with it.
Well, the question is again, we have several motions. We have
actually,
vibration.
that's a good point that I never considered. If the Earth turns, right, like that, turning what?
Spinning and moving around the sun.
But let's just keep the spinning for now. If you spin the Earth, does the molecule spin with it? Or does it?
Again, we have several issues here. If you take a piece of cardboard or something that's solid, the Earth turns, the cardboard moves.
Yeah,
okay, no problem there. Now we have a fluid like a river, or you have air around the Earth. The question is, do those molecules also rotate because of the motion of the Earth?
That's a good question.
And the issue is, first, before we can answer that question, is we have to answer if the molecule maintains its location, its position, its tilt, its orientation with respect to the center of the Earth at all times, let alone twirl sideways, does it maintain always the, like in the case of water, does it oxygen always point towards the center of the Earth, all else being equal? In other words, that you're not going to touch anything. You're going to let that molecule just sit there. And again, the question is, all this air that's enveloping the Earth, that's out there, that's just floating around with the Earth, around the sun and rotating with it, are those molecules, forget about the motion where they're twirling. We're talking about, are they even pointed towards the center of the Earth in a given direction? Are they tilted sideways or what? Before you do anything else, that's the first question you got to answer. Okay, and so unless we answer that question, the higher level questions on whether it's rotating.
Well, they're not higher level; they're just other questions.
Yeah, but I mean, this is a precondition.
Not
need
really.
to. It is. You need to
Oh, because
determine
you have
whether
to
it's
know-
pointed to the earth.
Yeah, okay.
Because if it does move, if it's standing on its head,
Then you have a
then
different
then you
scenario
can-
for the other one.
Right, absolutely.
In your model, light is traveling through the water. It hits a molecule and is then transmitted through the other side. What is preventing it from being retransmitted in any which direction?
But that's a question I still don't want to answer, because what he's asking essentially is, why is something opaque and why is something transparent? Right now we have problems with people thinking that light goes through atoms. Okay, and so that's the first question we got to resolve. I haven't addressed yet the whys, why one object is opaque, why another one is.
Are those September questions?
Probably so.
Okay.
So I'm not going to get into that
you have
yet.
To, you have to prepare the bomb.
No, it's
That's
it's
not a
question.
one-liner, is it?
First of all, it's a little more involved, but the issue is right now I'm having problem with people understanding the going through issue. They keep saying, "Well, how does light go through, and why do And so we got a problem with the going through, because the person who proposes going through first is proposing one-way mechanisms. Okay, one-way objects, such as particles or waves. And we've ruled out particles, we ruled out waves. So what do you have in exchange? First, you got to explain that. You got to defend your going through theory.
Okay.
That's what you got to do. And until you can do that, you've got no case. We got to destroy quantum mechanics first.
Okay, Pops, important questions.
Uh-huh.
If homosexuals are attracted to men, why do they speak with a lisp?
Good question.
That's it, I think.
Okay.
Any questions that aren't asked?
Okay.
Now, yes.
Yeah, just keep up for next.
We'll ask them next time.
Okay, then we'll see you on Sunday, and we'll start the new month with that. We'll see you then. Bye-bye.
Bye, guys. Have a good one.